Now you can hear me. Okay, again, thank you very much for the nice introduction. Thank you very much for having me here. I'm glad to be here. And I'm glad that some people are interested in Rust. Rust is an awesome new programming language, and Rust is also kind of very near to WebAssembly. And WebAssembly has, at least in my opinion, an important space here at a JavaScript conference, and therefore I thought it would be a nice thing to spend 3/4 of an hour talking about what Rust is. Not in theory, not based on slides where I tell you some architectural stuff or I show you some fancy charts with security incidents which are rooted in memory management and tell you that Rust is awesome in memory management. No, that is not what you can expect for the next 45 minutes. The next 45 minutes will be a single slide. This one, oh, let Ferris. This is the mascot of Rust. Let Ferris run here a little bit. So the gophers are the Go programmers are gophers, and we are crabs here. But in the next 45 minutes, we are going to take a look at a lot of Rust code. We are going to take a quick look at various tools around Rust, and then we are going to build an end-to-end sample. You will see some Hello World samples in the command line, so you have an idea how you could build server-side applications. But the most part we will spend writing some client-side code. We are going to build a hopefully exciting example that will comprise of TypeScript, of course, Webpack, and a lot of Rust, WebAssembly, and Wasm App, and tools like that. So that will be the course of the next 45 minutes. So first, why should you care about Rust? Well, I have one thing with which I would like to lead. Let me open my browser here. If you go to the Stack Overflow survey, I'm pretty sure that most of you are familiar with the Stack Overflow survey. And if you take a look at technology, and here go to most loved technology, guess what? Rust leads it with 86.1%. So that's a pretty impressive number, far in front of TypeScript. And if we change the year here, maybe to 2019, something like this, guess what? Rust, most loved technology. If we change it to 2018, yes, you guessed correctly, Rust, right in front of Kotlin. And if we take a look at 2017, guess what? Rust, #1. So there has to be something with this language if so many people love it. And this is what I would like to show you in the upcoming 45 minutes. Before we go into the topic, let me quickly introduce myself. My name is Rainer Stropek. I'm a passionate programmer. I write code for more than 25 years. I started my career in the C++ world, so therefore I have a heart for systems programming if you want. Then I switched to C#, JavaScript, TypeScript, Go, and many other languages. And in the last few months, I really fell in love with Rust. I am co-founder of a Rust meetup, this one, the Rust Linz meetup. And yeah, I do some Rust programming, and therefore I thought it would be a good idea to suggest this session and to spend the time with you. Please make this session interactive. If you have any questions that you would like to ask, go to your swap card, use the chat window there. I have the chat window here on the right-hand side, right beside me. And if you have any questions, feel free to share them. If you want to see the source code of the sample that I'm going to show throughout this session, I just posted the link to swap cards, so feel free to get it from there and clone it and maybe contact me in case of any questions. Enough theory, enough introduction. I promised you a coding session, so let's get right into it, right into the coding part. Let's start with some fundamental things. I am here in an empty folder, as you can see, and I would like to create a brand new Rust application. In the abstract of this talk, I told you that you do not need to know anything about Rust in order to get something out of this talk. So what is the first thing that you have to do in every language? Yes, create Hello World. And this is exactly what we are going to do. Well, the tool with which you create and maintain your Rust applications and libraries and whatever you want to build is Cargo. Okay? The Cargo tool is like npm for node. Okay, so whatever you do, if you manage dependencies and things like that, you do everything through cargo. So the first thing that we do is we say cargo new, and then we give it a name. Let's say hi-rust, for instance, and cargo new will create a new folder in this configuration, hi rust. Here it is, and inside of this folder, let me quickly open this folder up. We have a very simple structure. We have a so-called toml file. It's called cargo.toml. We have a source folder where we have a .rs file. And guess what? This is our famous hello world that you see here. And that's essentially it. If we would like to build this guy, we just say cargo build, and then cargo will restore all the dependencies that we have in our cargo toml file. You are all familiar with JavaScript programming. Cargo toml is like the package JSON file from the REST world. Currently, we don't have any dependencies here, but wait. We will build a larger example, or we will take a look at a larger example a little bit later on, and there we will have a lot of dependencies. So just like in package.json, we have here in this toml file the dependencies. Currently, we don't have any. So cargo build, the only thing that cargo build has to do is it has to compile our Rust file here, this main.rs, into an executable. And here come in some very important information for you. We don't have any runtime in Rust. Rust is, some people call it systems programming language. Yes, it is kind of very near to the system. So you are compiling down to machine language, really down to the metal. There is no garbage collector. There is no managed memory, nothing like that. But now you might think, hey, I'm not a system programmer. I come from TypeScript, JavaScript. I want to be productive. I want to write apps. And that's, from my point of view, one of the most important things with Rust. Yes, Rust isn't the most simple language on earth. Maybe it will take you a little bit longer than, for instance, learning Java or Kotlin or Go to learn and master Rust. But Rust is a programming language with which you can go down, very deep down into the system. You can write, I don't know, kernel drivers, something like this with Rust, definitely. You can build very efficient software for single chip computers, for, I don't know, an intelligent vacuum cleaner. But you can also use it to build applications, to build web APIs, to build client-side components which interact very nicely with TypeScript. The beauty of Rust is that it does not require you to be a genius like a C++ programmer, and otherwise, if you are not, your software will crash all the time. The Rust compiler is very, very chatty. It will check your code very thoroughly. It will tell you whenever you do something which is not appropriate, especially in terms of memory management, and that gives you a very good safety net. So if you write code and that code doesn't compile, there is a good chance that the code isn't correct. But if the code compiles, there is a good chance that it will just work. But you don't pay this safety net with performance for a garbage collector and things like that. You are still in a world where you don't have a runtime. You don't need a runtime. You are in systems programming mode, but you are nearly as productive as you are in a language, in a higher level language. If you are used to Rust, you are as productive as with Go, JavaScript, TypeScript, Node.js, and so on. Now here, this example is obviously very, very simple. By the way, this simple one here, indicates that we are using a macro here. Print line, this exclamation mark here means this is a macro. Macros are a very important concept of Rust, and we have another thing that you can take away from this session. Rust macros are, for some people, considered to be one of the most beautiful things in the language. You will see later on, when we build some WebAssembly stuff, that macros are used all over the place, and they save you from having to write a lot of code. The nice thing is that these macros are deeply integrated into the Cargo and Rust tooling, so you do not need to explicitly expand the macros. You do not need to generate lots and lots of code, for instance, like TypeScript to JavaScript before you can run the JavaScript, or Go and then run some code generator, check the generated code in and do something with it. That's not necessary. Rust macros are deeply embedded into the compiler and you don't see them. You can take a look at the expanded code if you want, but you don't need to. And in this case, this one exclamation marks saves us a lot of troubles. It allows us simply to write something on the screen without having to worry about the exact data types here. If we want to run this guy, that's pretty simple. We just say cargo run and it will run it and it will say hello world, as you can see. And if we take a look at target, debug here you see the executable. Okay, we could immediately execute that one too. So what are the first few things that you can take away from this first example? Rust is a systems programming language, but because of its quality of the compiler and because of its thorough checking of your code, especially when it comes to memory safety, Rust is a very productive language, even if you're not in systems programming mode, but if you are in application programming mode, either web APIs on the back end or some WebAssembly stuff on the client side. First thing. Second thing, remember Cargo. Cargo is the tool, just like NPM for JavaScript, the tool with which you maintain your projects. You create projects, you build projects, you automate the CI/CD process with the help of Cargo. You do dependency management with Cargo. Okay, so that is Cargo. Okay, let's leave it here for the very simple hello world and go one step further. I would now like to switch gears and go into a more complex example and try something with WebAssembly. And on our way, we will learn a little bit about Rust. Let's close this one. Let's go one up here. Am I in the right folder? Yes, I'm in the right folder. So now let's create a new project, but this time I'm going to use a project template with Cargo, and I'm going to use the Wasm template. Wasm stands for WebAssembly. I guess that most of you at the JavaScript conference know what Wasm is, WebAssembly. For those of you who are not that sure, WebAssembly is a very simple machine model, let's say a virtual machine, where you can compile other languages to. Typically, you take C, C++, Rust, and other languages, or Go, for instance, and compile it down to this WebAssembly format. And then you can run this code, this WebAssembly code, inside the browser or outside the browser, for instance, with Node.js. It's not machine specific, it's platform independent, and therefore it's a great way of making portable code which runs, as I mentioned, inside the browser, outside the browser, but because it's called WebAssembly, in a safe sandbox. That's the whole idea. WebAssembly, web, doesn't mean necessarily browser, but WebAssembly means code that is downloaded, that has been downloaded from the web, and I want to securely run it on my machine in a sandbox where I can make sure, or I can be rather sure, that it can't do anything bad. Natively, you could write WebAssembly code in a language which is called WAT, WebAssembly text, but nobody really does that. That's kind of assembler. So you typically take a language like Rust or C++ and compile it down to WebAssembly, and that's exactly what this template is going to do. It allows us to write Rust code and compile it down to WebAssembly. And then we take this WebAssembly and use it in our JavaScript code. In our case, inside the browser, but as I mentioned, it doesn't necessarily have to be the browser. It could be Node.js too. So let's run that one. Let's give it a name. Let's say this is hello-wasm, for instance, something like this. It created the project. Let's go into the hello wasm project here and again open it up in Visual Studio Code. My favorite editor for Rust is Visual Studio Code, so I will stick to it now. This is what we got. Again, we got a cargo.toml file, but this time it looks a little bit more elaborate. We'll talk about it in a second. Then here we have the source folder where we have a lib.rs. Again, a little bit more code, but as you can see down here, if I zoom in a little bit, here you see one major functionality, greet is here. And we also see a target folder. Here is where Rust would compile a little bit and tests and things like that. You know what? Let's quickly try to build that and see what's the result of that, and then we'll take a look behind the scenes. Let me see if I'm in the correct folder. I would like to go into hello. Yeah, I'm in the correct folder. I'm fine here. Let's call Webpack build. I'm not calling cargo here because cargo is only responsible for creating the WebAssembly code, but we want to go one step further, and this is what Webpack gives us. Give me a second, you will see it in a second. I'm now running Webpack build, and the first thing that it does, it's calling cargo build in order to build the Rust code into WebAssembly. Forget this warning, it's not important for now. The important thing is that we will ignore the target folder here, what I showed you with the hello world. Here is where we had our executable, but now we really see that we have a folder which looks very familiar for JavaScript programmers like we are. A package folder. Yes, and that is exactly what Webpack does for Rust. If you have Rust and you would like to run it in combination with JavaScript, with WebAssembly, you use Webpack as a kind of wrapper around the Rust tooling, and the result will be, on the one hand side, yes, a WebAssembly file. This is the executable, in this case a library, but not compiled to machine language for a certain machine or operating system, but this time for the WebAssembly specification. So any sandbox that can execute WebAssembly could now run this code. But we get more. What we additionally get is we get a bunch of JavaScript files, which are not that interesting, and also TypeScript type definitions. So here you see the export of the function greet that you just saw a second ago inside of our Rust code. See that one here? So here you see the TypeScript export, and here you see the Rust code. The Rust code doesn't look that strange. It's just a function. It's a calling to the alert JavaScript function, and then we see something which will be super important for the rest of the talk. Here we see a hash, and in square brackets Wasm bind gen. Wasm bind gen stands for WebAssembly binding generator. And the hash and the square brackets are again a macro. Here we see the importance of macros for programming Rust. Whenever you build applications, you are using frameworks, and these frameworks often come with macros to save you the heavy lifting of writing a lot of code. And in this case, Wasm bind gen will care for generating the necessary JavaScript and TypeScript code that is necessary in this case to call the greet method from JavaScript. So this is a macro which will generate, on the one hand side, Rust code that you don't see. It's a kind of glue code that makes this method callable from JavaScript, but it also controls the generation of the DTS files and JavaScript files. So keep in mind, macros are a really good thing. If you take a look at server-side frameworks, like for instance a framework that I like very much for building web APIs, which is called Rocket, there you again have a lot of macros that save you a lot of typing because they generate the necessary glue code for you. You can focus on what you really want to implement. Now the second thing that we see here is, in this example, it generated a Wasm bind gen over an extern specifier here. Extern means that there is an external method called alert, which takes a string and somebody else will define it. Guess what? That's the alert function that we get from the window object in the JavaScript browser. Okay? So with Webpack and Wasm bind gen, we can easily make JavaScript available from within Rust, and we can call JavaScript methods from Rust, and of course we can call Rust methods from JavaScript. And our Webpack build generated all that stuff for us. So now we have a ready to consume package folder, which we can, on the one hand side, take and commit to, or upload to NPM if we would like to share it with our peers or with the world, or we can just leave it here and build a small website. And this website just references this package through a, let's say, local path. And this is exactly what we are going to do in a minute. But first, let me introduce you to a few of additional examples here. If we take a look at the cargo toml file here, then we have to walk through the content of this file, because now this is way more interesting than we had before. Okay, we have a bunch of metadata. It's just like with package.json. That's not the interesting stuff. Let's zoom in to the thing that is down here, very interesting. First here, we specify that we are building a library. First, my first example, the hello world, was an app. It was an executable app that we could call, and it printed something on the screen. This time we are building a library, a Rust library, but also a C dynamic library. So that is necessary because we are using WebAssembly here. This just says library. Let's not discuss the details here. Now here we see the dependencies, and this is a typical dependency as you can see it in Rust. In this example, we are depending on a so-called crate. In Rust, we are calling these things crates, not packages, but crates. We are referencing the crate wasm bind gen. And the crates in Rust are not coming from npm, but there is crates.io. And if we say wasm bind gen, here you see, this is what you typically otherwise know from npm. This is how a crate looks in Rust. You see, we have versions, we have a link to the home page. We can take a look at the documentation. Here you see this is the home page, and here you see the documentation. Very similar to what you know from JavaScript and TypeScript. You have a little helpers text here, just as you are used to, but now you work with crates instead of npm packages. Another important learning here. Crates.io contains thousands and thousands of crates, and it would be way out of scope of this talk to talk about all the possibilities here. So just believe me, this is your npm if you would like to build applications with Rust, and if you want to publish some frameworks or libraries or reusable things in Rust, you will build libraries and you put it in crates.io or your own crates registry. Nice. So this is a dependency. Dependency in Rust are super powerful. And I cannot tell you everything and show you everything. I only have 45 minutes, but I would just pick out one thing which is super interesting from my point of view. And this is again another beautiful thing in Rust, which in my point of view, you don't have a similar thing in JavaScript. So-called features. Every library can come with optional and default enabled or disabled features. In this case, my library, the generated code, generates a feature which is called console error panic hook. I'll not go into the details. To make a long story short, it will print, in case of panics, very critical errors, beautiful console output messages. And you can enable that. That will cost you a little bit of performance, but make the code a little bit easier to debug. Or you can remove that feature, and then you don't get beautiful panic outputs in the console, but your code will be a little bit faster. So one would be the debug option and one would be the release option. But the point here is you can define your own features here. You can equip your libraries with optional capabilities. And then, this is the important thing here, you can have optional dependencies too. So you can say, I only depend on this crate if this feature is enabled. And if somebody is importing your library as a dependency, the consumer of your library can say, I want this library with or without this feature. For WebAssembly, in our case here, we can decide whether we want to build the WebAssembly file with certain features or without certain features. And inside of the Rust code, let me show you that, you can, with this again, macro, do a conditional compiling of certain statements or functions or modules by saying, okay, and this part of the Rust code only applies if this feature is enabled. So as you can see here, Rust often says the library comes with batteries included. You can decide, in fact, by using these features if you would like to have a library with batteries or without batteries, with the feature or without the feature. And with that, you can decide whether you want to have additional functionality, meaning also additional size of the library, or remove a little bit of size of the library and just import what you really need. So this is something which is really different from NPM and which we don't have in JavaScript in this, at least in this flavor. Okay? So these are typical dependencies. Now let's take a look at the code. Most of the code is not that important. The important thing up here, this is something that we will need in a second, is the use statement. The use statement is Rust's version of the import statement. Don't let yourself get confused. This is just a navigation between, let's say, something like namespaces, okay? Modules and things like that. But this just separates different namespaces, and I will not go into the details what a prelude is and so on. You can guess from the context what star means. I think you get the idea. Essentially, what we do, we are importing the macro Wasm bindgen and a bunch of other macros which we will need later on. So this is our new and great second sample, hello world sample, but this time not on the backend in the console, but this time in the browser. Can I already run this guy? No, I need a website for that. So let's create a website before we again switch gears and spend the last 15 minutes in a larger example where I can show you more features of the language. So let's create a small little application, and I will do that again by using, let me check here if I'm in the correct, yes, I'm in the correct folder, and I will npm init in a folder and I will use a template which is called Wasm App. Wasm App is a client-side app consisting of Webpack, an HTML file, a JavaScript file that imports a Wasm file created with Rust. So let's take a look at that. Here we have the subfolder, and down here we have a regular package JSON file. And if we take a look at the dependencies down here, I think I called it just hello Wasm like this. I can now here reference my my file by saying let's go down and use the package folder. So I'm now referencing here. I'm referencing the package folder which was generated from my Rust files with the wasmpack build command. So wasmpack build built an npm package containing a wasm file, and then we are referencing the wasm file for Webpack. Inside of my JavaScript stuff, you can see it here, I'm just, here, it was just called hello wasm. Here I'm just referencing this guy, this one. And this is JavaScript, but with a larger sample, which we will switch on in 2 minutes or so, which will be TypeScript. And this greet method here now is this greet method, and this greet method will later on call into the Wasm into our Rust code. So pretty straightforward, pretty simple. The Webpack configuration is a pretty straightforward Webpack configuration. Out of the box, the Wasm app template generates Webpack 4 code, but in my larger example, I will show you Webpack 5, so don't worry with that. Let's go into the folder here and simply call npm start. Or let's first call npm build, run build, of course, to see whether, npm install, sorry, forgot that one. Of course, we need the npm dependencies, and run build. Looks good, npm start. This should run our Webpack, looks good, and if I did everything correctly, we will see, here you are, hello Wasm, this call here, this alert call came from Rust. So we have HTML, which goes into a JavaScript. The JavaScript goes into Rust. Rust uses the Wasm bindgen to externally define another JavaScript method, and we came back from Rust into JavaScript and called a JavaScript method, alert in this case, and we have a message on the screen. And the development experience is pretty nice, because if let me start a new one here, and here, change that one, hello, iJS, for instance, let's put it that way, and say Wasm Pack build, something like this. It built everything, and if I go here, you see, Webpack automatically recognized that our Wasm file has changed. It automatically recompiled our app, and our application reloaded, and we see the updated file without us having to touch anything or doing heavy lifting with recompiling the applications in the correct order or things like that. It just works. Nice. So this was my second sample, and it showed you a little bit more about tooling, especially in combination with WebAssembly. It showed you what dependencies mean, and it showed you the power of macros as well as features as unique functionalities of Rust, which make this language really stand out from many other languages. I will now close that one and go back to my open sample here, this one, and maybe take a sip of water and take a look at the chat window. Maybe you already have some questions. No questions yet? That hopefully means that so far everything is fine. So what is the example that I would like to show you? Well, it's easier to demonstrate it to you than to describe it. I have built a small example for you, especially for this conference, and I've deployed it to the web. So if you want, you can try it yourself. And as you can see here, we have a nice little firework. I don't know if that comes through the web meeting and through Zoom. I'm not sure if you see the rockets exploding here. If you don't, I will just send the link here. If you want to try it, just click on it. And if it works, you should see some nice little rockets. That is WebAssembly, and I would like to walk you through certain aspects of the application that I built. We can no way go through the entire code in just the remaining quarter of an hour. That would be way too much code. But I would like to pick out some very interesting concepts about the language, and hopefully you take something with you, and that makes you curious about Rust, and then you can take my example and build on it. Okay, that's the idea. Now let's take a look at this example. The cargo toml file is very similar. The only thing is I added a bunch of additional dependencies, and one is especially important. I would like to mention that one. If you are a JavaScript web developer, you often have to deal with JSON, of course, and SERDI is a very famous library in Rust. Whenever you hear SERDI, SERDI stands for serialization and deserialization. This is essentially the go-to library when you want to serialize and deserialize Rust data structures into JSON and vice versa. So SERDI is really important on the server side if you're building web APIs, and on the client side whenever you consume or send JavaScript objects between JavaScript and Rust. Okay? Oh, I see fireworks in the chat. I love that. Okay, so let's take a look at the code. The code isn't too complicated here. As you can see, it's just, let's see, how much is it? 376 lines, so it's not that complicated, but still there is a little bit in it. So I would like to pick out some important things which you might not know yet about Rust. So if we take a look at the first page of code here. Guess what? Here. See that one? You already know what that is. It's macros. Oops, macros. Macros are important for Rust, okay? If you write Rust, you will use a lot of macros. That is normal. And if you write libraries, you will write a lot of macros. Macros are important. Macros are a super way for Rust to remove the need to generate or to manually write glue code. We just build a macro, and the macro can generate the code for us. We don't have to care for it. Everything is done by the tooling. We don't see the generated code. It's just gone. Now, This here is a typical data structure in Rust. It's just like, let's say, an interface or a class in JavaScript. No, in Rust we don't have classes, we have structs. And these structs can have behavior by adding methods, and you will see later on how this works. In this case, we have a firework rocket, and it has a color, it has an x coordinate, and it has a height to which it should raise, okay? So this is a very simple data structure written in Rust. Another important data structure that you see here, and this is probably kind of new for the JavaScript developers, are enums. This enum is rather simple. Rocket state. It means inactive. That means the rocket is currently on the earth, it's not flying, then it's rising, and at some point in time it's exploding, okay? These are the states. This looks very similar to what we know from, for instance, enums in TypeScript. But if we, for instance, say Rust result enum, if we Google that one, then we will see that enums can also have, you see it here, parameters. So an enum, each enum value can have a separate parameter. That sounds a little bit strange, and a result, for instance, is an enumeration, which is a typical result code of a method that can either indicate success, then it will return OK with the payload T, it's a generic type. The T is the result in case of success, and if it is not a successful execution, it returns the enum instance error with the property E, with the payload E, and this is special for the error payload. So enums have properties. That's important, and that's a very fundamental difference to, for instance, enums in TypeScript. This is an easy one just to get warm and started, to get started, but yeah, it's an interesting one. The next thing that I would like to draw your attention to is this one. This impl here implements so-called traits. Traits are a little bit like interfaces, but also very different. Everything is built on traits in Rust. Traits are all over the place. You influence the behavior of types by implementing certain traits on them. And for instance, here I'm implementing the system's default trait on my enum in order to specify a default value for a new instance of this enumeration. That is a trait. But there are traits for everything. There are traits for equality comparison. There are traits for serialization, for deserialization, and many, many other things. Very similar to interfaces in TypeScript, but in Rust we call them traits, and they have very unique properties which are unfortunately too complex and too time consuming to describe them fully here in this short talk. But just take away from this talk, in Rust, traits, TypeScript, interfaces, similar but also somewhat different. Now let's scroll a little bit down here. Here we have an interesting functionality. This functionality looks for an inactive rocket in a buffer of rockets. This application works like that. It allocates a number of simultaneously flying rockets, a buffer. Let's say 100 rockets can fly at the same time. And when the rocket is burned out, when it has exploded, the spot in the buffer becomes free again. And this one is an application. This is a function which looks for the first spot in the buffer that is currently inactive. So see here. Here you see iter, an iterator. Iterators are important, and if you come from JavaScript, that might sound familiar to you. It is like MapReduce, like the filter method, like the map method you are used to in JavaScript. This also exists in Rust. Very powerful MapReduce, or for C# developers, link style methods. In this case, I am looking for the first index where this condition applies. This is a lambda method in the Rust syntax. We have here the bound variable, and then here we have the filter criteria. So we are looking for the first element inside of our type, and this is a buffer of rockets. that is currently inactive. Now this position will not return something like -1 to indicate that it didn't find something. No, it returns, guess what, if we press F12 here, come on. I'm not here. I can show it to you here by hovering over. Come on. Come on, Visual Studio. Ta-da. Strange. Give me a sec. I would like to show you that. Rust Analyzer. It's here. It's enabled. It should be fine. Come on. You know what? I close this guy and I will reopen it because I would like to show you that one. Maybe I clicked, I guess. This one. So hopefully it works now. If not, I will, yes, here it is. Now it works. Sorry, maybe I haven't clicked on yes when this message box popped up. Here you see, and that's another typical thing that is returned in Rust. Rust returns from the position not a number that can be -1, and as a developer we have to know that there is the option that -1 indicates that it couldn't find an empty space. No, it returns an enum option. And then we have a very powerful syntax construct here, which is called match. Match means that we have to specify one code path for every enum entity here, and an option contains two different possibilities. None, which means there was no position which is empty, and some means there has one been found. And in the case of some, we get the result as a parameter to this enum indicator. And here we can do something with the index. And the beautiful thing, why Rust is known to be so stable, is that Rust forces you to specify a code path for every possible match criteria. So if I forget the none clause, I cannot compile this code anymore. And that is another typical thing for Rust. That is one thing why people say, yes, Rust is a systems programming language, but it makes systems programming way more robust, and it also makes Rust feasible for application programming because it disallows a lot of mistakes that we typically do as developers. Think of how JavaScript and TypeScript work. Typically, they would just return -1 for no position was found. And as a developer, you could forget that -1 is an option that you have to deal with. But with Rust, you have to deal with this thing. And I would like to show you one last thing, and unfortunately then, we are already at the end of this talk. Let me show you where this first interactive is used. This is a method here in HTML where the HTML code, the JavaScript code, can call the add method to add a rocket with certain parameters. But now look here. Here we see that we have this free index. It looks for the free index, but take a look at the result that we give back. And this is a method that is called from JavaScript. We do not return, again, a number or something like this, or we throw an exception. No, we return a result. Can you remember what the result was? Either OK or an error. In the OK case, we don't have a return value in this case, but otherwise we are simply returning a JS value. And now look at this question mark here. This question mark at the end of a method which returned result will recognize automatically that the call to this first inactive returned an error and will propagate this error to our own result. And guess what? TypeScript and JavaScript will make from a result with error, it will throw an exception automatically, and you can handle it in JavaScript with try-catch if you want. So it translates idiomatic Rust into idiomatic JavaScript, and that's really beautiful. This Wasm bindgen, what it does here. If it is successful, if I scroll down a little bit, we can simply return OK. And that is exactly what we wanted to do. And if we want at the end to run this guy, let's see, Am I in the correct folder? No, I have to go one down here and say Wasm Pack build. Let's build my example. Looks good. Let's go into the .dot folder just to prove it. Here you can take a look at the code on your own. You see this is beautiful TypeScript. I get IntelliSense. So if I say here firework dot, I get IntelliSense with the method names from Rust and so on. And here we say npm start. Go into where is it? I'm in the wrong folder. Yes, I'm in the wrong folder. npm start. Good. That will give us here. Let's take it from here. Localhost 8080. Currently a single rocket that explodes. But now I can go into my index.ts and, for instance, change the single rocket here to a set interval that just adds rockets to our Rust code, and that will lead to, you see, a nice little firework. And if we want to speed up the firework a little bit, this is now going into the WebAssembly code pretty quickly. If we want to make it even faster, let's say 300 milliseconds. Every 300 milliseconds we want a new rocket. That is pretty beautiful. And if we take a look at the performance here, just to show you that this is not only small and efficient and a beautiful language, but also powerful and fast. You see, we have here 60 frames per second, absolutely no problem, and still a lot of room to roll, although we are doing all the calculation and a lot of going on back and forth between Rust and JavaScript, and I think you get the point from this small little example. So, what should you take away from this talk? I didn't want to go into it and show you the whole power of Rust. It would take weeks. Visit us in our Rust meetup, for instance, if you want to dive deeper in. We also offer trainings, for instance, for Rust enthusiasts who would like to get into the language. But my talk today, I just wanted to show you some highlights from Rust, like the tooling, like the dependency system, like some little highlights in the syntax thing, how things are different and similar at the same time, and how beautiful Rust works side by side with JavaScript, TypeScript, Webpack, and WebAssembly, and so on. I hope it was an interesting session. I hope you took away a little bit from this talk, and I'll take a last look at the chat here. I think with that, I unfortunately have to close. I will stick around here in Swapcard for the next few minutes. So if you have any questions, let them come through the chat. For now, I have to officially close this session. If you have more questions and if you are curious, don't be angry with me that I close now. That is what I wanted to achieve. I hope you enjoyed this 45 minutes, and I wish you a beautiful rest of the International JavaScript Conference. Thank you for watching.